In this video, I want to have a look at equations with fractions. So let's jump straight into an example. If we have 3 plus n all over 5 is equal to 4. So we want to figure out what value of n makes that true. The first thing we're going to do in this one is we're going to get rid of this divided by 5. So to do that, we're going to multiply both sides of the equation by 5, and we'll end up with that 3 plus n is equal to 20. Then we've got to get the n on its own, so we'll subtract 3 from both sides, and we'd end up with n equals 17. Our second example, at first look, it looks very similar. So we've got 3 plus n over 5 is equal to 4. So the difference between our two equations is that in this one, that divided by 5 is only affecting the n, whereas in our first problem, it was affecting that whole 3 plus n term. So in this one, you could get rid of that 5 first, but it's probably easier to get rid of the 3. So we'll subtract 3 from both sides, and we'd end up with n over 5 is equal to 1. And then to get it on its own, we're going to multiply both sides by 5, and we'd end up with a final answer of n equals 5. So just being careful as to where your fractions, what they're impacting. For our third example, we've got x over 4 plus 2 is equal to x over 5 plus 3. So this is looking slightly more messy. We've got pronumerals on both sides and we've got fractions on both sides as well. So let's make it look a little bit nicer. If we want to get rid of this divided by 4, then we need to go through and times every single term by 4. So we'll times this by 4, we'll times the 2 by 4, we'll times this by 4, and 3 as well. So what that will give us, in this first bit, that just leaves us with x, plus 2 times 4 is 8. And on the other side, we're going to end up with 4x over 5 plus 12. So we've gotten rid of one of our fractions, but we still have this one over this side. So we're going to get rid of that 5 now as well. That means we're going to have to times everything by 5. So every single term multiplied by 5. And then we can go through and simplify. So this side will give us 5x plus 40 is equal to, in this one, those 5s will cancel out, leaving us with 4x plus 60. So we don't have any fractions left. We still do have pronumerals on both sides though. We've got 5x on one side and 4x over here. So let's subtract 4x from both sides of our equation. And that'll leave us on this side with just 1x plus 40 is equal to 60. And then our one last step is to subtract that 40 from both sides. And that'll leave us with a final answer of x equals 20. It's especially important when you're solving equations, but especially when they're equations that are a little bit messy to start off with and have got lots of steps in their working out, that you substitute this answer back into your original question to see if it makes sense. So for this one, we'd have 20 divided by 4, which is 5, plus 2 would give us 7 on that left-hand side of the equation. And on our right-hand side, we'd have 20 divided by 5 would be 4, plus 3 is equal to 7 as well. So because we ended up with the same number on both sides, 7, that means that 20 does satisfy that equation. All right, let's have a look at one more example. Okay, this example, we've got 12 over m plus 7 is equal to 10. So what we don't particularly like in this question to start off with is that m is in the denominator. So let's fix it. To get rid of a divided by m, we'll times by m. But if we do that, we have to do that to every single term. So we'll go through and multiply everything by m. So here we'll just be left with 12. Then we've got a plus 7m. 7m is equal to 10m. Then we've got pronumerals on both sides, so we'll get rid of the smallest one. So we'll subtract 7m from both sides, and we'll end up with 12 is equal to 3m. And then the last step is to divide both sides by 3. And that'll give us a final answer, if we flip it around and write it around the other way, of m is equal to 4. So those are a few examples of equations with fractions.